In this video, I'll present two approaches for the use case of automatically sweeping a token once it exceeds the threshold. It could be any ERC20 token on EVM chain, but I picked USDC to keep it simple. So imagine you have a wallet that frequently receives USDC. You don't want to keep checking it just to move the funds. You would rather have the tokens automatically sent to a consolidation wallet where they can be put to work in yield or lending protocols or anything else, instead of sitting idle and have zero capital efficiency. And one way to do this is with an off-chain keeper that sweeps any tokens above a set threshold. You would need to give this keeper a wallet and to spend your tokens, then make it listen for transfer events from the USDC smart contracts, or just pull the balance once in a while. The keeper will then compare the balance to the threshold and send a transaction to transfer USDC to the consolidation wallet. As you could see, there are quite a few steps involved here, and this is still best effort execution, no guarantees. To guarantee the outcome reliably, we can use Mimic blockchain automation protocol. Mimic handles all off-chain infrastructure and only leaves us to define what happens on-chain and when. So don't get intimidated, by the way, by this orbital diagram. Mimic abstracts all this away. You only express the logic in AssemblyScript along with the inputs available and submit it to the planning layer, which is the most inner orbit on the previous orbital diagram. The relayers pick it up from there and start watching your task. Once conditions are satisfied, an intent gets generated and handed over to the execution layer, which is represented by the middle orbit. And the most outer orbit is the security layer, which enforces correctness and validity of executions on chain. So now let's jump over to the actual implementation, and I'll walk you through coding a task, specifying inputs, and pushing the actual task on chain. So we're going to start off with installing the Mimic CLI tool. We're going to install it globally for convenience. Let's see what options it has. As you can see, it's pretty straightforward. And we're going to use these three: code gen to generate typed interfaces so we can conveniently work with them from the AssemblyScript, then compile to compile the task, and deploy to upload the compiled task to IPFS and into the Mimic registry. Let's go ahead and create the task. So let's move to that directory. The directory structures resembles a typical TypeScript project, except we've got a few extra files, and one of them is the manifest.yaml. So we're gonna take a look at it. And here we've got task descriptive metadata and external parameters that are configurable at runtime. Let's go ahead and change its name to token sweeper, and the description to monitor a wallet and transfer funds once a balance threshold is reached. We're not going to need the amount, as we're going to be transferring the entire balance. We're going to need to add the threshold, which denotes the token amount threshold at which a transfer is initiated. To interact with an ERC20 token, we'll need the ABIs to generate type-safe interfaces for the task. So let's specify where we will keep them. And I'm going to create the folder right away so I don't forget it. It's empty for now. We can grab the actual ERC20 ABI from Mimic docs. So let's head over there. It's in this build a simple task example. So I'm just going to grab the link address and download it with wget, save it in that new folder. Let's go ahead and check the ABIs. Here it is. So let's quickly generate types. We can do it with Mimic CodeGen. It validates the manifest definitions and generates the code to access the inputs that we've declared in the manifest YAML file, as well as the ERC20 methods that are defined in the ERC20 ABI that we've just grabbed. Let's go ahead and see what it has created in source types. These are the two files. ERC20 with the common methods, transfer from, total supply, decimals, etc. And index.ts, which is the interface to our inputs manifest file. Let's go ahead and open the task.ts file. We're not gonna need we don't have the amount. Actually, let's get rid of all this logic. We're gonna rewrite it anyway. And let's import a few more things. First of all, let's get rid of big int import. We're not gonna need it. ERC20 token, that's the wrapper to work with typed amounts and conversions. We're gonna need to import environment, which lets us access the task's execution context, like the user wallet. And we'll need log for logging messages in the web UI, so we can debug and monitor values. We're gonna need token amount. This helps us handle token amounts along with metadata like decimals and symbols, and we'll use it for conversions like to USD. The next thing would be transfer builder, which will let us build transfer intents and set a max fee cap. We're not going to need the transfer now that we have the transfer builder. Denomination token, it will let us get standard denomination like USD for our amounts. Then obviously we'll need the USD object itself. This represents USD amounts. We'll use it for comparisons as well as conversions. So that's it for the imports. Now we'll need the ERC20 that we have generated with CodeGen. This will be the ERC20 contract wrapper, and it lives in types / ERC20. So time to write the logic. The main function obviously is the entry point here. The first thing we're gonna do is instantiate a high-level ERC20 token object from the token address and chain ID. It will give us typed amounts, conversions, and formatting utilities. We'll call it token, and it is available as from using this from address method. Provided inputs that token and inputs that chain ID. Now let's parse the USD threshold from inputs and convert it into a typed USD object. Call it threshold. Now let's get the user wallet from the execution environment. First get context and then user. Now let's read the raw token balance directly from the ERC20 contract. And then wrap the raw balance in a token amount and convert it to USD. And handle any conversion errors afterwards. Let's also log the raw token balance. And its USD equivalent for debugging and monitoring. Now this is going to be our condition here. If the wallet's USD balance exceeds the configured threshold, value greater than threshold. We're going to build and send a transfer of the full token balance to the recipient and include the maximum fee as well. Let's build it and send. And that's it. The task conditionally moves funds based on the wallet's USD value using fully typed inputs and contract interactions. Now that the task template is ready, let's compile the task logic and manifest into deployable artifacts. Mimic compile is our command for this. So let's check out what artifacts it has produced in the build directory. As you can see, there's a wasm file, which is obviously gibberish to us as it's a binary. But the manifest JSON is pretty straightforward. It's just our YAML file turned into a JSON. So now that we've got the artifacts built, it's time to get the API key. For that, we'll head over to Mimic dashboard. Connect our wallet, generate API key, and we'll skip this part. The API key has been conveniently generated. I didn't have to click anything. So I head back to my terminal to save the API key in a local environment variable. For convenience, I keep my API key in a local environment variable. So for that, I'll head back to the terminal and export the variable. So now we can use that API key to deploy our task template, and the command for that is mimic deploy, specifying our key, which is in the environment variable. This will verify the manifest and recompile the task once again and upload the artifacts to IPFS and show us the content ID. So let's quickly verify that through the IPFS gateway. I'll copy this content ID, head over to ipfs.io, IPFS, and then paste that content ID. And here it is, the two artifacts that we have built with Mimic compile. So if we head back to the Mimic dashboard, this is a different account. The previous one I used for demo purposes to show how the API key is generated. And here's how I can create a new task. Pick the task template that we have just uploaded, the token sweeper. Click configure. Give it a title, token sweeper. Chain ID would be 42161, which is Arbitrum. Token address, the native USDC on Arbitrum. And the recipient will pick this wallet. Currently it has no USDC, and it will be easy to notice once some tokens arrive. Maximum fee would be 0.5, which is USD denominated, so I'm willing to pay up to 50 cents. And the threshold would be, let's say, 2. So once the balance reaches 2 USDC, the entire balance will be transferred. And for demonstration purposes, we're going to do every minute. That's the trigger. Obviously, we could pick a different trigger, the event-driven trigger to listen for the transfer event on the ERC20 token, which is in our case USDC, but I might leave it for the next time. Let's go ahead and sign with our wallet, and that successfully creates a task. This is the actual task instance that the relayers are currently monitoring. We see no executions yet. Actually, one has been since we have no USDC on this account, nothing happened. Let's go ahead and send some USDC to this address. We'll do 3 and make sure we pick Arbitrum and initiate, sign and send. USDC tokens have arrived, but they shouldn't be here for too long, because on the next run Mimic should pick it up and initiate the transfer. So let's go ahead and fast forward to that. As you can see, this recipient wallet still has no tokens, but they should arrive in a few seconds. The 3 USDC tokens that have been here just a moment ago have been transferred to this wallet. Let's look at how resolvers have dealt with it. We see the transfer intent has been generated by relayers, handed over to the solvers, and the intent has been fulfilled right here. So this is just one example of what you can do with Mimic. Beyond this, it supports use cases like automated dollar cost averaging, token rebalancing, fee collection, refunds, and even chained workflows like bridging assets and investing into Aave. They're shipping all the time, so follow them on X to stay in the loop. The code and relevant links are available in the description below. That's it for this one. Thanks for watching. Until next time.